Our dear viewers, you're welcome to another lesson about effects of electricity on substances. I'm teacher Ambassador Osbert, and I'm part of Back Science Education Consultants who are here to make sure that you continue receiving quality education from wherever you are. In the last video, we studied about the effect of electricity on substances, and we tried to demonstrate a few effects. We defined a number of terms which included the conductor, electrolyte, non-electrolyte, and several others like insulator. And part of this were part of the exercise that we are supposed to do and submit. I received a number of them, and I'm happy that you have good work done. Today I want to pick out only two definitions, and we zero on that for today's lesson. Okay. So I want us to look at an electric conductor. Among the answers I received, this is one of the best definitions that I picked out of the many that I received in my email, that this is a substance in solid state, that conducts electricity. And this somebody went ahead and said that this is because the substance contains free electrons, free and mobile electrons. Remember that in our first demonstration, we got wires, connected them at the ends of the terminals of a battery to a bulb, and then to a material which could either allow electricity to pass through it or fail the electricity from passing through it. And we tried a number of them. We tried an iron nail. We tried a knife. And many others, and we said these ones can conduct electricity. In conclusion, you will discover that all metals conduct electricity. Why? Because during bonding, when these are getting joined together, there is always a free electron that is from every atom that is participating in bonding. And because it is free, it can be mobile. When this energy from the battery goes through the wire, these electrons can easily move. And as they move in one direction, current will move in the opposite direction, and the bulb will end up lighting. In other words, we shall say that all metals and graphite All metals and graphite are good conductors of electricity. What do we want to emphasize here? Whenever a substance conducts electricity in solid state, provided it is in a solid state, then we call it a conductor. There is another substance called an electrolyte. An electrolyte. This is also a substance, but for it is in solution or molten form, and it can conduct electricity also, and can conduct electricity. And can conduct electricity. In this case, I want us to emphasize why is it necessary for it to be in solution form or molten form. In fact, when a conductor allows electricity to pass through it in the solid state, it does not change, it remains the way it is. But this one is decomposed. Is decomposed in the process. This is why we are looking at the effect of electricity on substances. Some substances don't change, but others, they get decomposed. They change. I want you to go and make research, and you at least outline any 4 differences between a conductor and an electrolyte. There are very many differences. Please go and check for them. Where you need more explanation, check on us on our contacts. We are around to keep helping you. These differences will show you that different substances behave differently towards electricity. We have seen electric wires that have been in the air for years. For years, every year this electricity is there, but you cannot use a dry cell, for example, for the whole year. It means that there are substances in the dry cell that cannot remain the way they are after conducting electricity. They are electrolytes. And so, this brings us to a process called electrolysis. Electrolysis. What does electrolysis mean? Whenever an electrolyte conducts electricity and is decomposed in the process, that process is the process that we call electrolysis. The process by which the electrolyte conducts electricity and gets decomposed is the one we call electrolysis. And remember, we said that there are 2 types of electrolytes. Some are strong and others are weak. But all of them, whenever they conduct electricity, they get decomposed. So this one is the decomposition. The decomposition of a substance in molten form, in molten or solution form. The decomposition of a substance in molten or solution form when current passes through it. when current passes through it. Now, there is something that we must note. There is something that we must note. For example, when you have salt in solid form, the crystals, they cannot conduct electricity. But when you get that salt and you melt it, you heat it until it forms a liquid, or you dissolve it in water, it can conduct electricity. So we shall say that electrolytes conduct electricity because they contain free and mobile ions. Free and mobile ions. You will realize that conductors conduct electricity because they have free and mobile electrons. These electrons can be there even in solid state and they are mobile. But when an electrolyte, when you have a substance that is in solid state, it means that the atoms that form the solid substance are fixed together, are strongly held together. And therefore, if they are strongly held together, it means that even when bonding has taken place, these electrons, these atoms cannot release the ions. In other words, if at all you have sodium chloride that is in solid state, the sodium atom and the chloride atom are strongly held that none of them can move independent of the other. But dissolving this sodium chloride in water or melting it is one of the forms of weakening this inter-ionic interaction. Weakening it to an extent that it reaches a point and it breaks. So that it breaks and you have sodium ion and chloride ion. The sodium will give the electron, will give chlorine an electron, so it becomes positive and this one becomes negative. And each one can move freely. They cannot be free if they are in solid state. But in solution or molten form, the ions can be released and so they can conduct electricity with ease. But in the process, they cannot meet again. The ions, after conducting electricity, they get decomposed. They get changed into some other substances. I want us to briefly draw this electrolytic cell and we label it together. This is an electrolytic cell that we drew last time to show the effect of electricity on the solutions and the liquids that we identified last time. And we say that electricity can pass through this provided it is an electrolyte. An electrolyte on a condition that it is in either molten state or solution state. We do not have any electrolyte that can exist in solid state. So this one must be either solution or it must be molten. It must be in molten state. Meaning that if this is our battery, when you complete the circuit, the electrons will leave the negative terminal. If the switch is completed. If the circuit is completed, the electrons will leave the negative terminal. They move through the bulb and they will enter this electrolyte through this other terminal, meaning that it will have to be negatively charged as well. So this should be negatively charged. An indicator that if that is negatively charged, then this must be positively charged. So after the electrons have entered here, then they will be interacting with the ions. Remember, we have said that electrolytes conduct electricity because they contain free and mobile ions. So the electrons from the battery will interact with the ions. And in interacting with the ions will change their nature. That's why we've said during that process, the electrolyte gets decomposed. Afterwards, the electrons will still continue and they will go up to the positive terminal. Meaning that current will be moving in the opposite direction. And that opposite movement of electrons and current will lead to the lighting of the bulb. The positive terminal is always referred to as the anode. And it is a point at which electrons leave the electrolyte. And then this other terminal is called the cathode. Both of them, anode and cathode, are generally called electrodes. They are generally called electrodes. Anode and cathode are both generally called electrodes. So we can call it a lesson, and make sure when you go, you look for the meanings of those two words, of those three words, and you continue making research. We are back science education consultants, and we are around for any further consultations. We beg that we meet again in the next video for more information about electricity. Bye for now.